Hi, this is Ms. McCullough, and this video will go through your Module 3 practice test with you on equations and inequalities. So this will give you an idea on how to do some of those questions that might have been challenging, and it will also give you some notes or some information that might be helpful so that you're successful on your test. Before we begin going through some of those questions, I just wanted to give you some information that might be helpful. And so for solving inequalities, this is a little cheat sheet, some steps that you can follow, and it will help you with some of the questions on your test. One thing I want to point out here is in this example, they're showing you, walking you through how to solve this example. But what I'd like to point out for you that oftentimes people forget is this last step. So this last step says negative d is less than negative 5. Now notice from step 2 to step 3, what they've done is they've moved the negative sign over. In other words, they've taken it and they've divided by negative 1 and divided by negative 1 to get d by itself. But what people forget to do is that when you're dividing by a negative like that, look at your symbol or your sign here. Your inequality goes from a less than to a greater than. Okay, before we begin, we want to make sure that you just refresh the symbols, have a little refresher on inequality symbols so that you have that for your notes and you know what to do for your test. So if you notice in the very first one, this symbol is a greater than symbol. I would write this in your notes so you have it. And when you're looking at it on a number line, this is the number line symbol that you would see. Now if we look, the next symbol to me looks like a slanted L. And so that's our less than, and you can see what that looks like. Other one, the only difference if you look here is the line underneath, and that tells you that it's equal to. So that would be greater than or equal to. And then the last one would be less than or equal to. So I would suggest you pause your screen really quick and write this in your notes so you have it so that you know what your symbols mean when you're dealing with inequalities on the test. All right, this first question says that Jacob wants to use an elevator to carry identical packages having the same weight. Each package weighs 3 pounds and Jacob weighs 99 pounds. If the elevator can carry a maximum of 300 pounds at a time, which inequality shows the maximum number of packages n that Jacob can carry with himself in the elevator if he is the only passenger? To do this problem, we want to set it up as an inequality so that we can solve it. So when we do that, we put everything on one side, and then on the other side, we usually put our total. So that's how we're going to set this up. Now, in this case, we know that our total is 300 pounds, and it's saying a maximum of 300 pounds. So that means that that's the greatest. It could be equal to, so we put the line underneath it. Now we know that each package weighs 3 pounds, but we don't know how many packages we need. So I'm going to put n because n represents the number of packages. And we also know that if we add that to Jacob's weight, which is 99 pounds, we want all of this to be less than 300. All right, so now we just want to solve that. And you remember we solve this by solving it kind of like we do an equation. So the first thing to do is to move the plus 99 over. And we do that by doing the opposite, which means we subtract. And 99 minus 99 is 0. Bring down your 3n. Bring down your sign. 300 minus 99, is 201. And then from here, we want to get n by itself. So we look, it's 3 times n. We do the opposite, which means we divide both sides by 3. 3 divided by 3 is 1. That would cancel. And so we're left with n is less than 201 divided by 3, less than or equal to, which is 67. So we know our answer should have been A on this one, or the first one. Okay, so this question says that Carol conducted a survey of 4 school cafeterias to find the number of students who like tacos for lunch. The results of her survey are recorded in the table below. Which school has the greatest percentage of students who like tacos for lunch? So here we want to look at our table and we want to be able to understand what it's telling us. So we have 4 schools. So A, B, and C, and D. Okay, now when we're looking at this and we're dealing with percentages, we have to keep in mind that our fraction always has our total on the bottom, and then on the top, it's whatever is unique to this situation. So in this case, it'll be our school. So if you look at school A, we can see, well, all of these schools, if you look, the total number of students is listed first. So these numbers in this column should be your denominator or on your fraction, the number on the bottom. So for A, I'm going to put 45. I know that's going to be on the bottom. Now, if you look again on this column, this tells you the number of who like tacos. So in that case, that would be on top. So here we know that out of school A, there are 12 people who like tacos out of 45. Now, that's a fraction and we want a percent. So let's go ahead and take that fraction and divide it, and we should get 0.2666, and the 6 goes on forever. Now, that's still not a percentage, that's a decimal. So to remember to move that over, we take our decimal and we move it over 2 places to the right. And so that tells us that our percentage is 26.6666. I'm going to just go ahead and put 0.7%. So this says that 26.7% about that many people, that percentage of people, like tacos in school A. All right, so now let's go to another school. Let's go to school B. Remember, the bottom is your total, which is 40. Top is 15. That's the total that like tacos. Now in your calculator, do 15 divided by 40, and you should get 0.375. That's a terminating decimal. That decimal stops. That's what terminating means. Now that's a decimal. We want to change it so that it's a percentage. So we take our decimal and we move it 2 places to the right. So that gives us 37.5%. So 37.5% of the people in school B like tacos. All right, let's do the next one. School C. We know that we have 9 people who like tacos out of the 27 people in the cafeteria. So if we do 9 divided by 27, we get 0.33, and it goes on forever, which is where you see the line. That's called a repeating fraction. So to change that to a percentage, we move it over 1, 2. So this is about 33.3%. Okay, last one is D. D shows us they like 13 people like tacos out of the 32. So let's see what that gives us. So in your calculator, 13 divided by 32, you're going to get 0.40625. Remember, we're changing that, so we take our decimal and we move it over 1, 2. So that's 40.625%. So about 41% like tacos in school D. So which school has the greatest percentage of people who like tacos? Your answer here would be school D. All right, this question says select true or false. The expression 4x minus 2, and then in parentheses 5x minus 1 is equivalent or equal to the expression 2 plus 6x. So let's take this expression and let's figure out what we can do here. Now, the first thing that should come to mind in a problem like this is that you see parentheses. And when you see parentheses like this, especially when you have a number outside of your parentheses, that's what you're sharing. It's called the distributive property. Now, this is where people mess up. That minus sign belongs to the 2. It always goes with what's behind it. So when we use the distributive property, we want to multiply both of these by -2. So when we do that, -2 times 5x gives us -10x. And then -2 times this minus 1 would be like a negative and a negative, which makes a +2. Notice the negative times a minus, which acts as a negative, and so that gives us a +2. We did not do anything with this 4x, so I can bring the 4x down. And then our last step is to combine like terms, put things together that have the same variable with the same power. And we can see that the 4x and the 10x, the minus 10x, both have an x attached, so we can put those together. Okay, and when we do that, we do 4 minus 10, which gives us negative 6, then we attach our x, and then we can bring the plus 2 down. We cannot combine these two terms. One has an x and one does not, so we cannot combine them. Now this question says to see if this expression is equivalent to this expression. And we can tell that it's not. That would not work because this is a negative. So the answer here would be false. All right, this problem says, what's the first step you would do to solve it? So I'm going to write it over here. Now the parentheses there are just there for organization. You do not need them. It does not ask us to solve it, but I'm just going to walk through some of the steps so you know how to solve two-step equations. The first thing we should do is look to find the x, and we can see that the x is attached to the 3 over 4. So always put a box on it around it because that's the last thing that I'm going to move over. First thing I should do is move this minus 3 over. And so we do that by adding 3. Because we always do the opposite. So cancel, cancel, that would give us 0. We can bring down our 3 over x. Bring down, now negative 16 plus 3 is negative 15. Okay, now in this problem, we want to finish solving it. And so we don't like the 3 over 4. We need to get rid of that. And so anytime we have a fraction and we want to move it over, we can move it over by multiplying by the reciprocal. I don't know if you've heard of that word before. Reciprocal. I think of it as recipe-flippy because you're taking this fraction and you're flipping it. And you're multiplying both sides by 4 over 3. 4 over 3 is the reciprocal. That's a fancy word that says that you should be able to multiply these two fractions together and it would give you 1. All right, so x equals, now 15 is not a fraction. I can make it a fraction by putting it over 1. And then I just multiply across when I have fractions. So negative 15 times 4 is negative 60. 1 times 3 is 3. And then I reduce. I think I can divide both of these by 3. And I see that this is negative 20. So x in this example is negative 20. Now I know this question did not ask you to solve it, but one will in the future, so it's good to know how to do it. In this question it says, what is the first step? So if we look back at our very beginning and we look at our first step, notice that our first step was to add 3 to both sides. Okay, in this example it says Shirley wants to buy a skateboard for $64. She has $98 in her account. She spent $10.85 to buy stationery. She also wants to buy some cookies for $1.65. What's the maximum number of cookies that Shirley can buy so that she has enough money left to buy the skateboard? So let's go ahead and come up with an inequality that would work here. Remember, when we do inequalities or equations and we write them out, our total goes on one side. So I'm going to put 98 over here. And that's how much money she has in her account. So that's the most that she can spend. She can spend up to that. So everything else has to be less than or equal to that. So let's include the $64 for her skateboard, plus the $10.85 for her stationery that she bought, plus she wants some cookies for $1.65. We don't know how many, so I put N. So everything that you see on the left side of our inequality here represents items that she wants to buy, and those items should be less than our $98. All right, so let's go through and let's just solve this. Now what I would suggest you do is start on the left side, and I would add like terms or things that are in common. So here we can see that the 64 and the 1085 can be put together. They're called like terms. and that gives us $74.85 plus $1.65n is less than or equal to 98. Okay, we solve this just like an equation. So now we want to get n by itself, so I always box that. That's the last thing I'm going to touch. And I'm going to go ahead and move this 74 over. So because it's positive, doing the opposite, which means I'm subtracting it. Not a straight line. So now what we have on the left side of the equation should be 165n, less than or equal to, and then 98 minus 45 gives us 2315. Okay, so now we want to finish solving this. So if this is $1.65 times n, to get n by itself, we do the opposite, which means we divide. And we're going to do 2315 divided by 165. And I'm going to put it over here. Those will cancel. So n less than or equal to 14.03. It goes on. Now, if you notice here, we're talking about the amount of cookies that can be purchased. So what's the maximum amount? You can't buy 0.03 of a cookie. That doesn't make sense. So here, our answer would be n is less than 14. 14 cookies or less. All right, in this question it says, the number of pages that Anna, Hillary, Roger, and Juan can read in a day is shown below. And it says Anna can read 15% of her 46-page book. Hillary can read 11% of her 72-page book. Roger read 12% of his 68-page book, and Juan read 14% of his 69-page book. Who can read the greatest number of pages? Okay, so anytime we see percentages like this, and we see the word of, we should always think multiplication. So of in math world means to multiply. Okay, so when we're looking at this, we have 15% of 46. Now remember, we can't just multiply the 15%. We have to take that and we have to move the decimal first. So if the decimal is not shown in this picture, you can assume it's at the end. And remember, we move it 2 places to the left. So this means we have 0.15 times 46. So if we were to do 0.15 times 46, that gives us 6.9. Okay, let's do the next one. Next one is Hillary, and Hillary can read 11%, which is 0.11 times 72. So if we do 0.11 times 72, that gives us 7.92. Okay, let's do the next one. Roger can read 12%, which we know is a decimal. Remember, we move it over twice to the left, which is 0.12 times 68. So 0.12 times 68 gives us 8.16. Okay, Juan can read 14% of 69-page books. So we put 0.14 times 69. 0.14 times 69. That gives us 9.66. Now, it says who can read the most? What do these numbers represent? You have to kind of know what you found. So what that means is if Anna can read 15% of her book, that means she can read 6.9 pages in a day. Hillary can read 7.92. Roger can read 8.16, and Juan can read 9.66. So who reads the most in a daytime? It looks like it's going to be Juan. Okay, so this question says that Jeff has 2 sticker printing machines. Each machine can print 42 stickers per minute. On day 1, only the first machine was used and it printed 89 stickers. On the following day, the first machine printed for X minutes and the second machine printed for Y minutes. Which expression shows the total number of stickers printed by both machines? All right, so each machine can print 42 stickers per minute. So that means that we have this for our machine number 1. And then for our machine number 2, we have this. 2 different machines. Now if we look here though, it says on day 1, only the first machine was used and it printed 89. So only this machine was used and it printed 89. So this was on day 1. So day 1 for this printer, it didn't have anything. Now if we look on day 2, this represents day 2. And here represents day 2 because both machines were working. So if we want to write this out as an expression, we just want to add everything up to find our total because we want to know how much did we do for both days. So we did 42x plus 42y, keeping in mind that these two represent day 2. And then we're going to add whatever we did on day 1. And day 1, it looks like the only thing we did was 89 on one machine. So this would represent day 2. So we just want, day 1, I'm sorry. We just want to look to see which one has all of that. So it looks like our answer would be C. Okay, question 9 says, in a dance competition, a participant has to score a total of at least 30 points. There's our clue. Keywords at least. In the first 4 rounds combine to move on to the 5th and final round. Stewart scored 5 points in the first round. So there's an important, let's kind of circle that number. He then went on to score additional points in the 2nd, 3rd, and 4th rounds. In each of those rounds, his score was identical. Okay, so that's going to be important. Which inequality best shows the number of points P that Stewart scored in each of the 2nd, 3rd, and 4th rounds if he earned a place in the finals? So let's start with our total. Remember when we're setting this up, we have total on one side of our sign, and we have everything else on the other. So if we look, it says that our total, it even says total, is at least 30 points. So I'm going to put my 30. Now, if it's at least 30, that would mean that it's 30 or more. So that means that everything else has to be greater or equal to 30. 30 is the smallest it could be. Okay, so then it said that Stewart scored 5 in the first round. So if we add up all our rounds, this would be round 1 plus. Now, if you look, he played a 2nd, a 3rd, and a 4th round. He played 3 more rounds. And this is the part that gets a little confusing, but is very important to keep in mind. It says in each of those rounds, his score was identical. So that means for all 3 rounds, whatever he had as his score was the same thing. So that's like saying 3 times X or 3 times whatever score he got. Now, we're not going to see this written because it tells us specifically to use a P. So I'm just going to change this, change my variable. And I'm looking for anything that looks like this. Now, keeping in mind, oh, we do see that on the very first one. So that would be it. Perfect. This question seems to get students a lot, and this is a good question that you could see on the ACT or SAT, and you'll also see this in algebra. So this says the sum of 3 consecutive numbers is 57. Which is the largest? So when we do this, we have to know our terminology or our vocabulary. So here the sum, remember sum means to add up, it's the answer to an addition problem, of 3 consecutive numbers. Consecutive means in a row. For instance, Monday, Tuesday, Wednesday are consecutive days. 1, 2, 3 are consecutive numbers. So this says the sum of 3 consecutive numbers is 57. Keep in mind, anytime you see is in math, is oftentimes just means equal. So let's try to translate this. We don't know what any of the numbers are, so I'm going to just make the first number x. And if I'm consecutive, that means I'm taking whatever that number is and I'm adding 1 to it. That would be my next number in my set. Now, if you follow that pattern, my third number in that set would be x plus 2. It's just going to keep that pattern. That pattern represents consecutive numbers. Okay, so if it says, and I'll just draw an arrow showing you that goes on forever. That pattern does for consecutive numbers. So here, we're only worried about the first 3. So I'm going to say x, that's my first number. And I should be able to take that and I should be able to add my next number, which is x plus 1. It's my second number. And I should be able to add my third number. It's my third number. And it should be equal to whatever my sum is, which in this case, they tell us is equal to 57. Okay, so what you just created here is your equation. Now we want to take our equation and we want to actually solve it. So to do that, we want to take and add like terms. Remember, a like term has the same variable with the same power. So in this problem, if we look, I'm just going to write it really quick here so we can work. Okay, let's go through and add up our like terms. So I'm going to box our like terms. We have 1x, we have 2x, we have another x here. So for our x's, we have a total of 3. Now look at your numbers that are by themselves. We have a 1, we have a 2, and that gives us 3. Okay, and I'm just going to bring the 57 down. And then if we look, we're going to take and we're going to move the 3 over. Remember, we get rid of that first. So that gives us 3x, these will cancel, equals 54. All right, so I'm going to write this over here and we're going to finish. 3x equals 54. Our last step, if this is 3x, remember that's 3 times, so we do the opposite, which means we divide everything by 3. And what you'll find is you'll find that x, these would cancel, is equal to 18. Okay, now you see 18 there. Is 18 the answer? Well, I want you to think about what you just found. Let's go back to our setup right here. Our setup was x, then x plus 1, then x plus 2. So our first number was 18. Our second number, if it's consecutive, would be 19. Our third number would be 20. They go in a row. And this question is not asking for the smallest number, it's asking for the largest. So in this case, our answer would just be 20. Okay, question 11 says, Bruno bought 96 pounds of sugar for his bakery. That's a lot of sugar. Every day, he used the same amount of sugar to make bakery items. After 10 days, Bruno was left with 15.2 pounds of sugar. On average, how many pounds of sugar did Bruno use each day? All right, so let's go through this question and then make sure we mark what we see could be important. So he bought a total of 96 pounds of sugar. That's going to be important. That represents our total. Every day he used the same amount of sugar. That's important. They tell you that for a reason. After 10 days, Bruno was left with 15.2 pounds of sugar. On average, how many pounds of sugar did Bruno use each day? All right, so let's set this up as an equation. Now, oftentimes when I set up an equation or an inequality, we've talked about this before, our total goes on one side and everything else goes on the other. So if we're looking here and we're trying to figure out how to write this, we know that he's purchased a total of 96 pounds of sugar. So when we set this up, we also know that he had 15.2 pounds left. So if we could take our 15.2 pounds and we could add whatever he used per day. Now this is the part that's a little interesting. It says after 10 days, and this is very important to keep that in mind because if he used the same amount of sugar each day, and we know that he used it for 10 days, that's why they tell you that, I'm going to just put X there, where X represents the amount of sugar that he's used. So I'm going to put that on the top, each day. So X is the amount of sugar each day. Okay, so oftentimes people get confused on how to write this out as an equation. And so this would be our equation, which the question's not asking for that. We're going to have to solve this. But keeping in mind that our equation usually has our total on one side and then everything else that he used on the other. Okay, now to solve this, remember I always box my X. That's the last thing that I'm going to touch. So everything else that's not in the box needs to be moved over. So if I have a positive 15.2, I want to move it to the other side of the equation, and I do the opposite. So if it's positive, I subtract, then I subtract, draw my line, okay? I'm doing 96 minus 15.2, and that gives me on the right side of our equation 80.8. Cancel this on the left side, that would give us 0, and then I can bring my 10x down. Okay, my next step, now we can get rid of the 10, so x is by itself. So because this says 10 times x, if it's together like that, we do the opposite, which means we take it and we divide by 10. This will cancel with this. So if we look, what do we have left with? Now, this is 80.8 divided by 10. I don't know if you know the trick here, but if it's divided by 10, that means take your decimal and just really move it over 1 to the left. So our answer would be x equals 8.08 pounds, because the question's asking how many pounds did he use per day. And if he did this for 10 days, each day he used 8.08 pounds. Okay, for question 12, it says Joan has red and pink hibiscus in groups of 9. She has X groups of red and Y groups of pink. Which expression shows the total number of hibiscus that Joan has? Okay, so there's a couple of things we want to see here. It says Joan has both red hibiscus and she has pink. So if we think about this, if we have red hibiscus, it's in groups of 9, and we know that she has X groups. We don't know how many, but we know it's X. So if each group has 9, we're doing 9 times X, which remember is the same thing as 9X. This is equivalent or equal, mean the same thing. Now if we look at our pink, I don't have a pink color, so I'll use orange right now, but pink is the same, groups of 9. We have Y amounts, so I'm going to times it by Y, which we know that 9 times Y is the same as 9Y. Now in this question it says which expression, remember an expression does not have an equal sign, shows the total number of hibiscus that she can have. So total means we're adding what we know. So if red is 9X and pink is 9Y and we're asking about total, we just take them and we add them. So 9x plus 9y would be our answer. Okay, this is a great question. This one says, the table shows the battery life of 4 different mobile phones, or cell phones, phone A, B, C, and D, and it tells you the battery life. If 8.45% of the battery life of each phone is used in a day by a typical user, which mobile phone would use a total of 1.69 hours? So there's a decent amount of things going on here. First thing we wanted to keep in mind here is we have a percentage. And it's saying we're using 8.45% of our total. So if we're using 8.45% of our total, there's a couple of things to keep in mind. I know we have another number here that we're going to look at in a minute, but let's take care of this percentage first. We notice there's an of, and earlier in the video we talked about of, and of means to multiply. So right away I could make this a multiplication symbol. We also talked about earlier that when we had a percentage, we cannot multiply it unless we take our decimal and we move it 2 places to the left. So find your decimal here and move it over 1, 2. And so this is the decimal that's equivalent or equal to this percentage. Okay, now to do this problem, we have to actually figure out our total. Well, each cell phone has a different total. So what you're going to want to do here, and I'm going to write it under each of these for organization, is we're going to want to multiply to see what we get. So if we take phone A and we take our percentage, we should multiply that by what our total is for phone A, which is 20. And if we do that, 0.0845 times 20, that's going to give us 1.69. Now if you go to B, same type of idea. Take your percentage, go ahead and multiply that by your total, which is 25. And you should see you get 0.0845 times 25, 2.1125. Now take phone C. Phone C, 0.0845. C is 10. Remember the trick with 10. When we're dividing, we go to the left like we saw in the previous example. When we're multiplying, we take our decimal and move it over to the right one if it's 10, if it's a multiple of 10. So this means we have 0.845. Okay, and then our last one, 0.0845. Multiply that by your total of 18. And that's going to give us 0.0845 times 18, 1.521. All right, so it's important to know what you just found. And what you just found here with these numbers represents the total hours of battery life. The battery life. And in our case, we didn't have to work that hard. I just wanted to show you so you knew how to do it. But it says the total of 1.69, and that was actually our very first one. So we could have stopped there. I just wanted to make sure you understood how to do this type of problem. Okay, you should be ready for your test. If you have any questions or concerns, or you want help with anything else before you take your test, feel free to call me or email me. If you need additional notes before your test, here is a great link that you can click on, and it will give you some extra notes and some extra examples. This is great for the entire year, so take a look at it. It's great to have. All right, well, good luck on your test and have a wonderful day.